Now these set of problems are going to talk about three characteristics or properties of rational functions. So we talked about the domain in the last video, so we have that one already. We have vertical asymptotes and horizontal asymptotes of the function. So along with the domain, we're going to now talk about the characteristic vertical asymptotes and horizontal asymptotes. And that's simply an imaginary line that our function gets close to after a certain value. So now let's take a look at one of these here. Let's see, which one shall we do? We can do number 12. We'll try number 12. That's this one here. So I'm just going to rewrite it off to the right here. So that's going to be f of x equals x over x squared minus 9. Okay, so first we're going to find the domain. So that means I'm going to factor the bottom. And the bottom is a difference of squares. So that's going to be x plus 3, x minus 3. And again, I got to set it equal to 0, of course, because I want to find out what doesn't work here. So my x is going to equal negative 3 or 3. So the domain then is going to be negative infinity to negative 3, union negative 3 to 3. Let me fix that 3. Union 3 to infinity. So that's my domain. And now we have to find vertical or horizontal asymptotes. So now the way this works is the vertical asymptotes are easy. That's where if my rational function is in lowest terms, which means I can't cancel anything out, which I can't here, because I would have to factor this in order to do that. And in factoring it, I'll show you what I get here. And I can see here easily that nothing cancels out. So that tells me there that all of my, or where my bottom is 0 at, are my vertical asymptotes. So this tells me if I was to write that out, I'll just write vertical asymptotes. And that's going to be at x equals negative 3 and x equals 3. Now again, we represent vertical lines by x equaling some number. So those are actually equations of vertical lines. It's not I'm solving it for x or anything. No, those are vertical lines, and that's how I represent them. So those are my vertical asymptotes. Let's talk about horizontal asymptotes now. This one's a little more difficult to explain and actually to understand. So the idea of a horizontal asymptote is I'm actually looking at the function f of x. Now I'll take the original one. I think we see it a little better here when we're looking at that one. So this is x over x squared minus 9. Okay. So the idea of horizontal asymptotes is I'm watching the y values here. But I'm trying to pick large numbers as my x goes to positive and negative infinity. So that's hard to explain in words. Even hearing me, you're probably like, what? So what I can do here is, the idea is let me take x equals 100. And if I take this x equals 100, I'm going to get 100 over, and that's 100 squared. So that'll be 10,000 minus 9. So that would be my y value when x was 100. So one thing you notice here is this 9 that we see here, as we continue to go out, is going to have less and less of an effect. So what I'm going to do is I'm just going to take it out, because we're going to go a lot higher than this. So we don't really have to worry about it as much. So if you notice my y value here is like, I could take a few of those zeros away. That y value turns out to be around 1 over 100. And that's where x is 100. So again, it doesn't have to be exact here, but we can see how much effect that 9 was really having there. And it's not that much. Now watch this. Now I'm going to go x equals 1,000, because keep in mind here, I'm going to take my x as it goes towards infinity. So now if I pick 1,000, I get 1,000 on top, and I'm not going to worry about the 9 again, because look at where I'm at now. I'm taking 1,000 squared, so that's 6 zeros. And now if I was just subtracting 9, honestly, you could hardly tell if you think about it. So there's my other y value now. So now if I cross those off, I'll cross off 3 of them. I'm going to get 1 over 1,000. So now I'm going to pick 10,000. Okay, I should try to put this in some sort of order here. So hang on. So now I'm going to get x equals 10,000. So then my y is going to be 10,000. That's 5 zeros. No, that's 100,000. Take 1 away. Okay, over 10,000 squared. So 1, 2, 3, 4, 5, 6, 7, 8. So then if I cross those 4 off, I'm going to get my y equal to 1 over 10,000. And hopefully you start to see here that as my x's get larger and larger, my y's are getting smaller and smaller, because first I have 1 over 100, then I have 1 over 1,000, then I have 1 over 10,000. So as my x's get large, my y's are getting really small. And when I talk about horizontal asymptotes, it's the y values that are creating those. So if we continued this process, we would see that as x goes to infinity, now this is the one that's going to continue to go up. As that goes to infinity, my y is going to go to 0. So what that tells me here for my horizontal asymptote, I have a horizontal asymptote at y equals 0. And one big way we can really tell this is take a look at all of these rational expressions here. And notice on the top, just a constant is degree 0. And on the bottom, we have degree 1, which the degree on the bottom is larger. So notice that even for the second one here. And notice the third, and the fourth, and the fifth. Now the fifth has or the number 14 here, has a difference of 2 degrees on the bottom. But you guess what here? Keep in mind here, if I had a 10,000 there, I'm taking 10,000 times 10,000 times 10,000. So what we'll see there is it's going to be a lot larger on the bottom than it is on the top. And that goes for all of these problems, except for these last 2. So now we're going to take a look at this idea now. But if we see that the degree on the bottom is larger than the top, we're always going to end up with a horizontal asymptote at y equals 0. So now let's take a look at number 18. We'll do 18 next. Now remember, this problem we did here, this was number 12. Okay, so now let's try 18. So that's going to be f of x equals x minus 4 over x plus 6. And right away we can see here that negative 6 x cannot be, because that makes the bottom 0. So my domain then is going to be negative infinity to negative 6 union negative 6, comma, infinity. So we just had one jump. Very nice. Now let's talk about the vertical asymptote. Now the vertical asymptote is just going to be x equals negative 6. Now the horizontal asymptote. Now for that one, again, we're going to have to do that sort of analysis. So think of it this way. Let's start at x equals 10,000. Let's start big. Then I'm really going to get, for my y value, I'm not going to worry about the 4 because I'm going to go quite large, or the 6 on the bottom. So that's going to be 10,000 over 10,000. Okay, so that's going to equal around 1. Now again, it'll be a little less than 1 because I got 6 more on the bottom, but close enough to 1. Now, if I go 100,000, that's going to be 100,000 over 100,000. And hopefully you're starting to see that, hey, I'm going to get right around 1 for each of these. So this tells me my horizontal asymptote is going to be y equals 1. So that's the number there. So keep this in mind for these problems here. Notice that when the degree on the top and the bottom is the same, I just get the 1 over the 1 here because there's a 1 on top and a 1 on the bottom. So I'd get 1 over 1, which is 1. Now notice this number 19 here. You might want to work through that. But what you'll notice for that horizontal asymptote for this one is going to be y equals 4/3. Because it's those numbers in front, the multipliers, that are going to give me that 1 over 1 that we've seen for all of these over here. So that's how that works. So again, this horizontal asymptote for number 19 is going to be y equals 4/3. Oh, not 4/3, I'm sorry. Let me fix that. I was just looking at the first one. See, that's what I get for that. It's actually going to be negative 2/3. I apologize. Because when you look at that, think about where I'm plugging it in here. I'm plugging in the 10,000 in for that one. That's going to be 20,000. And then I plug in the 10,000 here. And that's going to be 20,000 over 30,000. And that's where I'm going to get the 2/3 because I have the negative here as well. So that's where that comes in. I apologize. So when I look at that, I look for the coefficients in front of the highest degree term, or I call them the leading coefficients, when the degrees on the top and the bottom are the same. All right, there it is.